All right, this is your spring semester exam review. Your exam is going to be 17 questions, multiple choice. This review is longer than that, but you can expect these type of questions on your final exam. So the first page is a review of logs and exponentials. So this is the last unit that we have done. So in number 1, you're supposed to complete the chart below by rewriting each of the following in the other form. So you're given an exponential, and in order to change it into a log, you can use your block letter L. So remember what this means is you're going to have log base 2 of 8, and then it backtracks to equal 3. So this is going to be log with a little 2, big 8 is equal to 3. And it works the same way with fractions, so you don't have to worry about things changing just because it's a fraction. So I can rewrite this as log base 9 of 27 is equal to 3/2, or 3 over 2. And then when you're changing logs into exponentials, you can use your little e. So you start at the base, or the smallest number, then you go over to your answer and loop back to the number. So this is really 4 squared is equal to 16. And again, even though it's a fraction, it still works the same way. 8 to the 2/3 is equal to 4. Okay, so again, those are just rewriting. They're not solving or simplifying. You're just rewriting in one form, or from one form to the other. All right, so the next section is solving logs. So on number 2, because I have the same log base in all 3 terms, I'm going to simplify and condense this left side into one single log and the right side into one single log. Remember, your coefficients really become exponents. So this is really going to be 2 squared times x times 3 is equal to 6 squared. Because when we condense this into one single log, you don't have to worry about the plus signs anymore. When you condense and get rid of your log, it becomes multiplication. So when I simplify this, 2 squared is 4, and 4 times 3 is 12. So this is going to be 12x is equal to 36. And then when I divide both sides by 12, you should end up with x equals 3. Okay, on number 3, this says log base 3 of 81 is equal to x. In this type of problem, you can just plug that into your calculator by going to math and then arrow up twice. So now I have the log base 3 of 81, and that tells me that x is equal to 4. If you wanted to, you could change it into an exponential, but this is a surefire way that you're going to get it correct is just by entering it into your calculator. Okay, number 4, we have log base 9 of x is equal to negative 1/2. So in order to solve for x, you are going to have to rewrite this as an exponential. So we're going to have 9 to the negative 1/2 power is equal to x. And at this point, I would again suggest putting this into your calculator. So 9 raised to the, so 9 raised to the negative 1/2 power. And that gives you this decimal. You'll see it as fractions on your exam. So in order to change that decimal into a fraction, you can press math and then enter twice. So that tells you that x is equal to 1/3. So again, how I change that decimal into a fraction is by pressing the math button and then enter twice. And that works anytime. Okay, number 5. We again have the same log on both sides. So I'm going to condense this left side and set it equal to the right side. So this, remember, your coefficient goes into your exponent when you condense. So this is going to become 5x squared is equal to 125. X squared and 5, like if you switch these two, it would be the same thing, but normally we see the number first, then the variable, so that's why I wrote it that way. So then I divide both sides by 5, so then I get x squared is equal to 25. And then once I take the square root of both sides, you can get the positive and the negative solution of plus or minus 5. And again, how I got there was taking the square root of both sides. Okay, number 6, we have 4 to the power of x is equal to 671. So in order to solve this, I'm going to change it into a log using my block letter L. So this is log 4 of 671 is equal to x. And then I can go plug that into my calculator. So log 4 of 671, and that tells me that x is equal to 4.695. So in number 7, we have 6 to the power of x minus 2 is equal to 5. So before I change this into a log, I have to isolate the exponential or get it by itself. So I'm going to go ahead and add 2 to both sides. So then we have 6 to the power of x is equal to 7. And then again, in order to solve this, I'm going to change this into a log. So we're going to have log base 6 of 7 is equal to x. And then I can plug that in my calculator. Log base 6 of 7. So that tells me that x is equal to 1.086. All right. So the next section on here is factoring. This is towards the beginning of the semester. Remember, there are different types of factoring. There's factoring trinomials, which is 3 terms, and then we're also going to have sum and difference of squares and sum and difference of cubes. You guys will be given a formula chart on your exam that will be projected onto the screen, so you do not have to memorize these formulas. All right, so number 8, we have 3x squared minus 8x plus 5. So this is a trinomial because they have 3 terms. First thing you want to check for is a greatest common factor, which we don't have one because there's no number or variable that I can take from all 3 terms. So what you have to do if there's no GCF is you're going to take your first term and multiply it by your last term. So 3 times 5 is 15. Then we're going to make a list of all the possible numbers that multiply to be 15. So we're going to have 1 and 15 and 3 and 5. Of these number combinations, what you're looking for are 2 numbers that add to be your middle term. So in our case, we're looking for 2 numbers that add to be -8. So since this is negative, but 15 is positive, what that means is both your 3 and your 5 are negative. Okay, so we know that we're going to use these 2 numbers when we factor. So now we have to go and make the box. My first term goes into the first box, so 3x squared. And then my second term comes from the first number in your number pair, so that's going to be -3x. And then -5x comes from the second number in the number pair. And then your last term comes from your original problem, +5. So when I factor this, remember you're looking for 2 numbers that multiply to get you to this window. So this is going to be x and 3x because those multiply to be 3x squared. 3x times -1 is going to get you to -3x. And then x times -5 is going to get you to -5x. And then you can double check because -5 times -1 is positive 5. So that means that your factors are 3x minus 5 and x minus 1. A shortcut to this, if you can't remember this process, and this is a multiple choice exam, FOIL these two things and see if you get back to your original problem, which, if you remember, FOIL is multiplying your first terms, your outside terms, your inside terms, and then your last terms. So you can always use your answer choices to work backwards in case you get stuck. Okay, and number 9, we have another trinomial, but this is nice because I have an x, at least one x in all 3 terms. So that means I can factor out the x as your greatest common factor. So once I factor out an x, I'm left with x squared minus 6x minus 27. So then, because I have a coefficient of 1 here, I'm looking for 2 numbers that multiply to be negative 27 and add to be negative 6. So I can use negative 9 and positive 3. So I'm still going to have the x that I factored out, but then this can be broken down into x minus 9 and x plus 3. Because again, negative 9 times positive 3 is negative 27. Negative 9 plus 3 is negative 6. And this is your final answer. So as long as you have a leading coefficient of 1, you don't have to make the box. It's when you do have a leading coefficient of something other than 1 that you have to make this box. Okay, so number 10, x squared minus 16. This is a difference of squares. I know that because x squared is a perfect square and 16 is a perfect square. Just to remind you what perfect squares are, they're the number or the numbers that are the product of the same number multiplied, meaning like 1 times 1 is 1, 2 times 2 is 4, so that means 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. So since these are both perfect squares, I can break this down into the square root of each of these terms. So this is going to be broken down into x minus 4 and x plus 4. So you can see that I took the square root of x squared to get to x, the square root of 16 to get to 4. Again, you will have this formula on your formula chart for your final exam. So in number 11, it's similar because we have 4x squared minus 81. So these are both perfect squares because the square root of 4 is 2 and the square root of 81 is 9. So that means that I can factor this into 2x minus 9 and 2x plus 9. That would be your final answer. Okay, number 12 and 13 are dealing with sum and difference of cubes. Again, you will have those formulas, but just so you have it on your review, the difference of cubes, I know it's the difference because I have a minus sign, so this is going to be a minus b times a squared plus ab plus b squared. Now, a and b are the cube root of whatever you have in your original problem. So a is not x cubed, b is not 27. A is x, b is 3. Again, I know that because the cube root of 27 is 3. You can check that in your calculator. I can go to math, and then number 4, and type in 27, and that tells me that the cube root of 27 is 3. So if you're not sure, please use your calculator. So that's just the a minus b part. So now a squared is going to be x squared, and then if I multiply a times b, that's going to be plus 3x, and then plus b squared is 9. And then this would be your final answer. So the sum of cubes is similar, it's just that your signs are a little bit different. So this is going to be a plus b times a squared minus ab plus b squared. Again, these two formulas will be given to you. The difference in number 13 is that we're going to have to factor out a GCF from both of these terms. And the reason I know that I have to factor out a GCF is because 5 is not a perfect square and 40 is not a perfect square. But I can factor out a 5 and get x cubed plus 8. X cubed is a perfect square, 8 is a perfect cube, and 8 is a perfect cube as well. So now I can break this down into x plus 2, because 2 is the cube root of 8. And then I'm going to have x squared minus 2x plus 4. And again, this would be your answer. So the key thing to remember is when I have a and b, it's not your original numbers, it's the cube root of your original problem once you factor out the GCF. All right, so the next section is simplifying rational expressions. So when we simplify rational expressions, you're going to want to factor everything first, and then you can cancel factors if you need to. Good news is there's only multiplying and dividing, so you're not going to have to find a common denominator. Please do not find a common denominator. That's going to throw you off. So on number 14, we have a division problem. So remember, with division, you have to keep, change, flip. So you're keeping your first fraction, you're changing your sign, you're flipping your second fraction. So I'm going to factor this at the same time. So when I factor x squared minus 9, this is a difference of squares. So I can factor that into x minus 3 times x plus 3. And then when I factor the denominator, what I'm looking for are two numbers that multiply to be 9 and add to be negative 6. So I can factor that into x minus 3 times x minus 3. So I kept my first fraction, it's just factored. Now I'm going to change that division sign to be a multiplication sign, and then I'm going to flip my second fraction, meaning that the denominator is going to become the numerator is going to become the denominator. So now this is going to be x minus 3, and then I have to factor this. So this factors into x plus 3 times x plus 3. So signs are super important. These are both positive because a positive times a positive is obviously a positive, and positive plus positive is positive. Negative times negative is positive, but negative plus negative is negative. So please watch your signs. And then at this point, we can start canceling. You can cancel anything that appears in the numerator and in the denominator. It doesn't matter which fraction it's in. So I can cancel this x plus 3 and this x plus 3. I'm sorry, minus 3. Sorry, I just canceled the minus 3's. Then I can cancel this x plus 3 and this x plus 3. I can cancel x minus 3 and x minus 3. So even though that I've canceled everything in the top, I still have a 1. And then in your denominator, you're just left with x plus 3 because everything else had been canceled out. And that's your final answer. So once you factor it, it's really not difficult. You just got to make sure that you know how to factor. On your exam, your leading coefficients are always going to be 1, which should also be helpful. All right, so looking at number 15, this is a multiplication, so we can just factor and cancel. So I'm going to have x plus 5 in the numerator. Once I factor the denominator, it's going to be x minus 5 times x minus 5. Again, because negative times negative is positive, but negative plus negative is negative. X squared minus 25 is a difference of squares, so I can factor that into x minus 5 times x plus 5. And then in your denominator, that can be factored into x plus 5 times x plus 5. So now that everything's factored, I can start to cancel. So I can cancel x plus 5 and x plus 5, x minus 5, x minus 5, x plus 5, x plus 5. It just so happens that we cancel everything in the top again. So it's going to be 1 over x minus 5. If you were to cancel everything in the denominator and the bottom, it would be over 1, whatever you have left in the numerator, over 1. So I think this material is what's going to be the most difficult on your exam, but find ways to work backwards if you can. And again, you will be given those formulas for sum and difference of squares and cubes. Good news is this next page is just matching your graph. So what I would do is I would put each of these into y equals and then just go match them up. So just to remind you how to enter some of these various things such as absolute value and radicals and all that good stuff. So in order to get to your absolute value bars, I will remind you of this on your exam. You're going to go to math. You're going to arrow over to number and then press enter because we're finding the absolute value. So I'm going to have x minus 2 and then plus 3. I'm going to go ahead and put all 4 of these equations on here in the same y equals. That way, these are color. You can just glance at one graph and not have to go back and forth and back and forth. So this function is going to be negative, and then you get to your square root by going to second x squared, because you can see your little square root in blue. So that's going to be x plus 3. And then the next equation is negative x plus 5. Make sure you close your parentheses before you square it. And then minus 3. And then you can make your numerator and denominator fraction by going to alpha y equals. So you're going to have x minus 1 over x plus 3. And then I can go graph all of these. Your blue is your first graph, so this graph is showing up in blue. This graph is red. This one is black. And then the last one is pink. So we have all of these graphs. So comparing these, it's kind of hard to fit it all on one screen. But you can see that the blue graph has that V shape, so that means this one is C. The red graph is most similar to D. The black graph is your parabola, which matches up with B. And then your rational, this fraction one, is pink, which you can see on 2 parts of your graph, which follows most closely with A. Okay, so just put those in your calculator and match the graph. Those should be gimmes as long as you know how to type it in. Okay, almost finished. So it wants us to sketch the polynomials of each of the following using the roots of the functions. Just a reminder what your roots are. Roots are the opposite of whatever you can see in your various factors. So on number 20, my roots would be negative 2, because I got to switch the sign, positive 1, and negative 3. Okay, so then I can go graph those. Negative 2, kind of making my own scale here, positive 1, and negative 3. Then if you're unsure what the graph looks like in between there, again, just go graph these, or graph this whole function in y1, I'm going to have negative and then negative parentheses x plus 2 parentheses x minus 1 parentheses x plus 3. So you can see it crosses at negative 3, negative 2, and 1. So I can just set that on here to match that shape. Obviously, it is not perfect. I don't really care if it's perfect. I'm more concerned about your roots and the overall shape of the graph. So on 21, the roots of this, because I have a GCF of x squared factored out, that automatically tells me that I'm going to have a root at 0. I'm also going to have a root at positive 1 and at positive 3, because again, you got to switch your signs here. So I can plug this into y equals and sketch my graph after I've drawn my roots, 0, 1, and 3. So we're going to have x squared, parentheses, x minus 1, and then x minus 3. So this one's a little hard to see, but you can get the overall idea. It has a bounce here at 0, and then it's going to come up and then cross. So I'm going to go down. I'm going to do a little bounce up. I'm crossing through 1, dipping before I come back up through 3. Again, it's not a perfect match in your graph, but roots are the most important thing that we're looking for here. All right, the next two problems are dealing with variation. Again, these formulas will be given to you. So direct variation is y equals k times x, and inverse variation is y equals k over x. So in number 22, if y varies directly as x and y equals 18 when x is equal to 24, we're trying to find x when y equals 15. So if I know that y is 18 and x is 24, then I can substitute those values into your formula. 18 is equal to k times 24. So then I need to find out what k is. So I'm going to divide 18 by 24. So I find out that k is equal to 0.75. So now using this k value and this y value, I can now find what x is. So I'm going to have 15 is equal to 0.75 times x. So then in order to find out what x is, I'm going to divide both sides by 0.75. So that tells me that x is equal to 20. Okay, so it's kind of taking things apart and then putting them back together. So in number 23, if y varies inversely as x, you're using this formula, and y equals 40 when x equals 12, I can write this as 40 is equal to k over 12. So in order to find out what k is, I multiply both sides by 12. So I get 480 is equal to k. So now I'm trying to find y when x is equal to 15. So I'm going to plug in my k value of 480. So y is equal to 480 over 15. So I can go ahead and divide 480 by 15. And that tells me that y is equal to 32. And that's your final answer. All right, and then the last two are simplifying radicals. So when you simplify radicals, remember what you're looking for are perfect square factors. And we touched on this earlier, but your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So what I'm trying to do is break up 360 into perfect square factors. A way that you guys can easily find factors, if you go to y equals and you type in 360 divided by x, and then you can go to your table, which is second graph, it will give you all the possible combinations of numbers that multiply to be 360. So I know that 4 and 90 work because 4 is a perfect square, but if you look down here, I can also see that 10 and 36 are factors of 360. You want to find your largest perfect square factor, which 36 is our largest perfect square factor. So I can break this down into the square root of 36 times the square root of 10. That looks like a 7. It's a 1. 10. So the square root of 36 is 6. So that means that this simplifies to be 6 times the square root of 10. Again, if you get stuck, you can always work backwards. I can find the decimal value of 360 to be 18.97. I can also find the decimal value of 6 times the square root of 10. They should be the exact same thing. So again, use test-taking strategies if you get stuck and work backwards. All right, so it's similar when you have a coefficient. I'm still going to break this down into its perfect square factors. Now, the only perfect square factor of 12 is 4. So I'm going to break this down into the square root of 4 and the square root of 3. Now, the square root of 4 is 2. So that means that I can multiply 7 times 2 to get 14 times the square root of 3, which would be your final answer. Again, you could check those in your calculator if you wanted to do 7 times the square root of 12 and check it with 14 square root of 3. So there are several ways to figure out how the best answer if you get stuck by working backwards. So just as a reminder, wrap up 17 questions, multiple choice. You will get your calculator as well as a formula chart that has all of the necessary formulas you will need. Good luck.